This video was brought to you by Squarespace. Create a great website with no experience. More on that later though. Welcome back to another video, another session, another day, another dunk. If you're new around here, hello, my name is Thomas Randall. I'm trying to make a video game. That's about it really. All you need to know. We're doing physics at the moment. A little bit of a physics rework. So, good news. The videos where I'm asking for resources have finally come out and you guys have come in clutch with some lovely, lovely resources. So starting off, really nice video that I watched the other day. Why does Celeste feel so good to play? I actually watched this a while ago, but I didn't really pay much attention to it or take notes on it, which is kind of yucky. And the only good thing that I really got out of it was this right here. This running curve. So quick acceleration, even like twice as quick at decel, and a few things like coyote time. You can still jump a little bit after you run off a cliff. Doesn't sponge the input, and jump queuing, same kind of thing. It's all about whatever the player does, whatever their intention is, they press a button, they expect it to happen. I've kind of been doing a bit of thinking, right? We want to make a really nice, realistic game. So going to have to compromise a little bit for responsiveness. Just a teensy bit. Because we could have it entirely responsive like Celeste, and that leads to like a really nice responsive feel. But I kind of want to add a bit more realism into the mix without sacrificing too much of the responsiveness. We've got to hit that sweet spot of like, all right, this looks amazing and it feels amazing to play. It may sound impossible. It may sound completely mutually exclusive, I think is the right word. But I reckon we can hit a sweet spot somehow. It's all about in that fine line, you know? That's not what we are going to be doing today. Today, we actually have to get an entire physics system built out again. Offline, I actually did a little bit of work and I put the VOD up on the archives channel. Basically, what we did is I just hopped in a Discord call with the boys and we just did a little bit of work. We got some stuff done. So we basically yeeted the entire physics system and just started again. Didn't really start again, just doing it with a blank slate, and we're trying to understand impulse resolution again from scratch. So right now, where we're at is basically this. There is no collision at the moment. Well, there is collision detection. We just have to resolve that collision. So if we were to actually put a brake here, if we were to just crash right here, as soon as it hits the ground, boop, we do have collision, right? So we just got to resolve that. Whoa, what's that smell? Oh, it's the smell of an amazing looking website with... For those of you who don't know, Squarespace is an all-in-one platform that lets you create a website with absolutely zero web development experience whatsoever. Now, why is that so important? I don't know. Why is getting an online presence important and building up a niche little audience on the internet? Because it allows you to monetize your passions. I don't think I need to explain why monetizing your passions is good, but I'll do it anyway. It's fun. Imagine rolling out of bed in the morning and actually enjoying your job. Wow, that's crazy. Squarespace could be a good starting point for actually getting the ball rolling on that, right? Step one, don't look at the other steps. Step one, that's all you do. Execute, baby. And you can whip up a website for that thing in no time at all. Their tools are so goddamn easy to use, and most importantly, they've got an entire platform for handling whatever monetization scheme you come up with. Whether that be physical goods, services, membership content, you can do it with Squarespace. Beyond just monetization though, they've got all the tools necessary for you to actually create content. Create a blog, SEO the shit out of that blog, create a portfolio, market the shit out of that portfolio, create a newsletter, send the shit out of that newsletter. You get the picture. The possibilities are only limited to your imagination. So head on over to Squarespace, follow the link in the description, and when you're ready to go live, you can use my code RandyTheSequel at checkout for 10% off of your first purchase on a domain name or website. The world is your oyster, baby, so go do something with it. Thank you, Squarespace, for sponsoring this video, and back to the content. I found another quite interesting little piece of knowledge from one of you champs in the comments who linked to this physics tutorial series. Physics from scratch. Where have you been all my life? Look at that, 17 videos. Oh, everything you need. I'm not too sure how useful this is going to be, but just looking over the titles, it looks like there's a lot of good stuff in here. That's really what we're going to be doing today, is just sifting through a bunch of these tutorials, seeing what's up, seeing what's good, and hopefully re-implementing impulse resolution or whatever we decide to do. Strap in, boys. That's what we're gonna be doing. Let's get cracking.
Hey guys, what's up? My name is Gabe and this is Games with Gabe.
Games with Gabe, my man.
Even if you are familiar with vector math, you need to be like super familiar, because when you're doing this physics code, if you don't understand what crossing two vectors is and how that relates visually and how that is actually affecting real life objects and stuff, then you're not going to be able to follow along very easily with mathematics.
Side quest? Yikes. You see, I've actually got quite a good idea for learning math. talk more about that in a little bit though. Maybe next video.
And then we'll also be doing oriented rectangles versus oriented rectangles.
I actually implemented SAT by myself back in the C++ engine. That was one of my only achievements in that game engine.
We will finally go into the last chapter of this, which is manifolds and impulses. So this is where it gets it ties everything together, and it's also one of the hardest sections.
So that's literally what I'm about to do right here. We have the manifolds up here. These are being generated with the help of Qt-C2, Randy Gould's single header library for generating collisions, manifolds, if you will. You may think that I just want to do absolutely everything myself from the ground up, but if there is a genuinely good solution to it that I can literally just use, then I fucking will. Basic vector math. Let's do some basic vector math, boys. My God, there's a lot in here. There is quite a bit. Let's go.
The x is 1 plus 2 is 3. 3 plus 7. Good to think of it in terms of points and vectors. We flip the direction. Okay. Now b is not just 1. So I don't know any times that I've actually ever really used the most common thing. But dot product basically works as if you have two vectors, you add them together and you get a scalar number. This is just a number in the end. It's not a vector.
All right. So, quick pause. If you were to give me two vectors right now, vector A and vector B, and ask me to do a dot product on them, I probably couldn't. Let's bust this myth. All right, 3, 4, 7, 6. Dot product of these two. Isn't it like 3 times 7 plus 4 times 6? What are we thinking, chat? Yay or nay? Yay, I'm not entirely useless. Let's go. Cross product, on the other hand. I know cross product returns 2 components. Still have no idea though. No clue. No clue. Cross product is where my current understanding breaks down. By the way, I didn't just look at I definitely didn't cheat and just look at this and remember that. Trust me.
If you had more components, say it was X, Y, Z, W, you would just multiply the Y's, add, multiply W's, add, and continue down the chain. It's not too hard to remember, but it may not be apparent at first what this means.
It really isn't. That's where my understanding breaks down. What the fuck even is it? I know how to do it, but I don't know what it is.
The dot product has a direct relationship to the angle theta between the two vectors. I say relationship because this is not the angle. It's related to the angle. So we can intuit things about the angle based on the dot product value.
And it's like if they're both pointing in the same direction, if they're both perpendicular, perpendicular? That's not perpendicular. If they're both parallel, then that means the dot product will be 0, maybe? I don't know. Again, with the cross product, I don't know how to do it. I have no intuition there. So, you know what we're gonna do? That's what we're gonna do. Probably not today though, but we will do it eventually. You know what? I should probably stop right now before we even move ahead and understand all this. I kind of need to understand basic vector math before even continuing with this. You watch 3 blue, 1 brown? You see, sure, I could go and watch a 3 blue, 1 brown video on linear algebra. But the thing is, you can't just look at information and just kind of absorb it without doing anything, without putting it to practice. That's why Brilliant is goated, because it gives you the theory and it also gives you a way to actually practice it. Whenever I try to go understand something, just kind of sitting there, just fucking doing this, right? You're probably not going to take anything in. You need to interact and actually take action. Watching videos just ain't it for something like that. That's why we need to bring out the big guns. I'm just going to watch the rest of this video, see what I need. Back to like easy peasy. That's just some good old fashioned Pythag, baby.
We know that the length of A we can denote by A squared plus B squared. And so that's how you get the length of a vector.
So it means that it has a length of 1. So how do we get a length of 1? Well, first we get the length and then we divide both X and Y by the length. I don't think that's right. Let's see what this man does.
Fits. And now A is a unit vector. This is now of length 1, and we can...
I actually did it. Yay. I don't know why I thought that was wrong. Hey, trust myself more, man.
So A dot B is equal to the cosine of theta, right? What this means is that if A dot B equals 1, then that implies that theta is 0, which implies that the vectors are parallel.
Remember a little while ago where I said if they're parallel, it'll equal 0. I would like to formally apologize and take back that awful comment. It is 1.
I really wanted you to know how they are explained visually. If we're ever going over something and you can't remember how it is visually and I don't explain it, go back to this video, because this is so important that you understand what is happening on your screen visually and how it relates to the math that we're going to be doing, because physics uses a lot of math. That math always has a relationship to how it's actually behaving in the real world.
Amen. All right. So solution, we understand how basic vector math works. Not really down pat, because if you were to hold a gun to my head and ask me to do a cross product, I would probably die. Real quick, I'm going to figure out how to do mathematical notation in Obsidian. That seems like it would be useful for this. Look at that. Yay. My first ever mathematically notated formula. Well, I guess I can't really continue on here today without hopping in Old Mate Brilliant. So I guess we'll carry on with that next time. I could continue on with the tutorials, but I feel like at this point, I really need to just knuckle down and actually learn all this before even continuing, because like, what the fuck is the point? Time to actually understand things. All right, peace out, boys. Thank you very much for tuning into this video. Bit of a quick one today because, like I said, I need to get my shit sorted with Brilliant before actually moving on to do that. Cool. Take care. Bye-bye.